Okay, our next talk is another timely one. And I think this is kind of important because the role that we operators have in providing the sort of the statement of needs for bandwidth is very important, and the IEEE and Ethernet Alliance, I believe, are both very interested in that. So we have a presenter from Brocade, Scott Kipp, who's also involved with the Ethernet Alliance, and he's going to talk about the next speed of Ethernet.
All right, thank you. Yeah, and I also want to talk about bandwidth growth. You know, everybody knows the bandwidth is growing, more users, faster speeds. What we want to do is give you some rules of thumb, some ways to wrap your head around these huge exponentially growing numbers. And then we'll go into the next speed of Ethernet. Now, how many know what the next speed of Ethernet is going to be? All right, so a new crowd. I was surprised because I got on a plane the other day and the guy sitting next to me knew what it was. You know, it was only a week before that we'd met in Geneva and talked about going to 400 gig as the next speed. So we pretty much have consensus on 400 gig being the next speed. But first off, I need to give a disclaimer. Didn't seem to work. Sorry, a little technical difficulty. Okay, there we go. So the views I'm expressing are my own views. I can't represent the IEEE or even the Ethernet Alliance, even though I'm the president of the organization. So with that said, just one slide about the Ethernet Alliance. I mean, we're a global consortium of stakeholders in the Ethernet industry. And with respect to this group, what we want to be is a funnel for you to give us your input. We can refine it and then present it to the IEEE to help us decide how to do the next speed, how quickly, what kind of reach, what kind of media to do it on. And we'll go into that in more detail. After we help develop the standards in the Ethernet Alliance, we also test it. This week, we're having the largest plug fest ever of over 20 companies at the University of New Hampshire interoperability lab. So we're testing all 10G base T, 40 gig, and data center bridging this week. So first, we want to look at a new study that we just finished in the IEEE about bandwidth growth. How fast is it growing? Here's one summary slide, and what we found out is there's really two growths. So we drew two lines on here. The line that's growing faster is for networking, the aggregation traffic that you guys deal with every day. What we're seeing is that it's doubling every 18 months. So that's one figure of merit. The one I prefer, though, is really every 5 years we see a factor of 10 growth. Every 10 years we see 100 times growth. We'll give some examples of that coming up here, but that's, you know, one figure of merit that you can use, or one rule of thumb. There's a lot of variation within that. But if you know how we went from 10 gig, the consensus was that we're going to go to 100 gig. What we found out is that a lot of people wanted, especially the server industry, weren't growing at that same rate, so they wanted 40 gig. And that's what's represented by the lower line there. There you see a 10 times growth every 15 years. So on the horizontal axis, it's in 5-year increments. On the vertical axis, it's factors of 10 for bandwidth growth. So you can see in the network, it's growing 10 times every 5 years. In the server space, we aren't growing as fast. It's doubling every 2 years, more closer to maybe Moore's Law. I think most people know that the network bandwidth is growing faster than Moore's Law, typically. So if you had like 10 gig in your network in 2005, in 2010, you multiplied that by 10, so you're up to 100 gig. If you keep on that rate, by 2015, you're going to be at a terabit already through. That's like aggregate traffic in your network. So how fast of speeds do we need to get to support that kind of aggregate bandwidth? That's what we've been studying in this report. And so the report is released. Here's the information how to get that. There's a white paper. It's got a lot of pictures for you, so you don't have to read all the time. You can scan through it. But the final report, I think the fourth bullet down there, You can just go online. It's readily available for everybody. Here's one of the pictures from it. This is from Cisco's Visual Networking Index. So it's a very good, it's a database basically. You can go on the website and pull up all kinds of information. What we're seeing here is the IP traffic is growing about 32% a year. So if you follow the green bars there, that's your fixed access, your fixed line, with the old Ethernet cable into the laptop or server. It's growing over 40%. It's the majority of the bandwidth today, and I'm sorry, it's not growing. It'll be 46% of the traffic in 2015. What we're seeing is the wireless connectivity is growing faster than that, and will just about match it in 2015. So, once you have your laptop wirelessly, we don't run cables throughout this room, right? Everything's wireless. It's so much easier in your home in a conference like this. What we're seeing a lot faster growth, of course, is in the iPhones or, smartphones. We're seeing 92% traffic growth a year for the smartphones or the mobile data. So we're seeing it's just a very small sliver today, just a couple percent, but just by 2015, it'll be about 8%, and it's going to continue growing like that. So it's really amazing the transformation we've gone through, just in the last few years. Just think 5 years ago, very few people had smartphones. Now almost everybody has them, right? At least techies like us. So here's a slide that I put together. I did quite a few presentations for this on data center growth. So starting at storage, we entered the zettabyte area of million terabytes. And think about it, now about the size of your cell phone, you can have a terabyte disk drive. So, I have a backup drive that's about a terabyte. So when the bigger company, EMC, IBM, and them put 1,000 of these in a couple racks of storage, you got a petabyte of data right there. So the storage is becoming so cheap that it's enabling a lot of these new applications. The computing power, of course, is growing right with it according to Moore's law. We had our first petaflop supercomputer in 2010. Individual servers now are going into 10 gigs of I/O. I have a lot of stats coming up for you about how servers are going to 10 gig now. We're finally seeing that hockey stick growth that people were expecting, a decade ago. And then finally we have networking, right? We've entered the 100 gig era a couple years ago. And individual switches have terabits of bandwidth within a chassis. We're seeing individual switch blades having over a terabit of throughput too. So all those are coming together to create this bandwidth explosion. You have increased storage, you have the increased processing times the increased bandwidth, and you get, bam, a big explosion like the 4th of July in San Diego. I don't know if you guys followed that, but they have a big fireworks display in San Diego, 5 locations in the Bay. There's a computer glitch that blew it all off simultaneously. The whole show that was supposed to last 18 minutes, be all orchestrated, blew up in 18 seconds. So it's just one big explosion. Well, we're seeing that kind of condensation of data and throughput in our networks today. So that's what we're trying to quantify. So looking a little bit closer at storage here, this is external storage subsystems. And in 2005, 130 exabytes sold. In 2010, we saw about that 10 times growth so that we entered the zettabyte era. So that's 1,000 exabytes. By 2015, we're not going to see quite as much of that. But then this is physical data that gets stored or shipped every year. The network, it's easy because you're just sending the bits over the wire. This is stored bits, so it is quite a bit different. And what even changes more than that is like the number of files, because we have all these people with big digital cameras or 12 megapixel, 16 megapixel cameras, taking pictures everywhere. They store them all the time. They send them to friends. They upload them to Facebook. They get backed up, replicated. This data is it's growing at a mind-boggling pace. And that shows how there's this exponential growth when you look over like 5-year periods. For servers themselves, this is a very telling chart. You see the red bars across there, that's all your 1 gig servers. Now, this is ports shipped, so individual servers can have multiple ports. So as we do server virtualization, we're getting more throughput through each server. So one server might have 4 gigabit Ethernet ports. At some point, they come to a point where, well, it's not easy to put 6 gig ports on a server. Let's go to 1 10 gig or 2 10 gig ports. So that's the big transition we're seeing right now. I mean, this is from the Ethernet perspective, this is the biggest transition the industry is going through, is 10 gig server ports escalating. I mean, we expect it to outship 1 gig ports in the next couple of years. This is from Crahan Research here. But think of how this ripples through the network. If you have 10 gig uplinks, or uplinks from the server, the uplinks into the core of the network have to be even higher speed than that. So that's what's driving the 40 gig, the 100 gig, and eventually 400 gig, especially when these servers get to 40 gigabit per second. So here's a study of the network. This is some recent data that Martin Pels of AMSIX presented at an Ethernet Alliance panel at ECOC in Amsterdam last month. So what he's showing is the exponential growth of the aggregate network in the Euro IXPs. So if you look at 2006, we were they were about 1 terabit per second. So if you look 5 years later, 2012, it looks like they will be over 10 terabits per second. So this is an updated chart from what's presented in the bandwidth assessment report. So you can go there and the data is 1 year behind. So this is the latest data for you. But what we're seeing then, so 10 times growth every 5 years and 100 times growth every 10 years. So if you go back to 2006, you see it's under 1 terabit. They're predicting 90 terabits in 2016. So 100%. So just think of that. What 1% of your data today, or all of your data today, will be 1% of the traffic a decade from now, if you're growing at this rate of about 58% compounded annual growth rate. So these are this exponential growth that's just really hard to grasp. Doubling every 18 months, 10 times every 5 years. You know, when they first came to the IEEE, AMSIX has been one of the leaders of coming into the IEEE and showing us how much they're growing. So they came in 2007 and said, yeah, we're going to grow all these terabits, and I was hesitant to believe them, actually. But here we are 4 years later, and it's right on track of what they were predicting. So they have more IXPs joining their network, more users at each IXP, people logging on more hours. You know, in aggregate, it's this amazing growth rate. So we took a lot of this data just from all the end users. What we wanted to do was consolidate it into, we'll give a bigger perspective and show what variation there is. So this chart just explains this chart here. So what we did was we took at Unity, or all the data was normalized to 2010. So at 2010, you have a relative value of 1. Where's your data going to be in 10 years from now or 5 years from now? How long is it going to take to go up an order of magnitude of your bandwidth? So if you start at the very top curve, Andy Bach of the New York Stock Exchange, when he worked there, he saw a CAGR of over 90%. So that was doubling or going up an order of magnitude every, 3 or 4 years. Now, if you follow the red dash line intersects, from Unity to the very corner. So in 2020, it's right at 100 terabits per second, or 100. If you had 10 gig in your network in 2010 and you're on that growth rate, you're going to have 100 gig at 2015 and a terabit at 2020. Now going down to the lowest curve, that's the IP traffic. It's growing at 32%. So you see it doubles about every 8 years. And I'm sorry, it goes up an order of magnitude every 8 years when you're growing about 32%. So again, a lot of numbers. Sorry to hit you with all these, but I got more to come. There's a lot more in the spreadsheet, but this is basically the conclusion of that bandwidth assessment report that you can download and check out for yourself. So now on to the next speed of Ethernet. This is a real hot topic for the industry. We always want to go faster, consolidate, see the latest technology. So we'll show you why, I'll show you why it's 400 gig and not terabit. I know there's been a lot of publicity about terabit Ethernet, but we just don't know how to do it. We're running to get into the laws of physics. I shouldn't say that. We know how to do it. It's just a matter of making it cost effective. We need to not, we've sent people to the moon, right? It just takes a lot of money to do that. We could give you a terabit Ethernet. It's just going to be very expensive, and we don't want to have a repeat like of what we've seen with 100G base LR4, where it's been real expensive. People see the price tag and they'll wait to buy it. Ethernet has always been a low-cost networking solution, so we'll show you about that. So I told you about the 10 gig servers growing. Here's some stats from Crahan Research. So on the left side, you see the number of 10 gig server ports, and you see it's been growing. It actually stalled a little bit right before 2011. I think that's why, because people were waiting for the Romley server to come out. And the Romley server is designed for 10 gig and specifically for 10G base T. So if you look at that growth in the last couple of quarters, and then you break it down in the right side of the graph, that's 10G base T. 10G base T has this hockey stick effect where it's growing tremendously. This is the kind of 10 gig growth rates that really make the jump in the curve. So 10G base T has been very powerful before, like high power, like consumes too much power to incorporate into a server. Now with the latest processes, it's under control, and so it's starting to be deployed quite a bit. So Romley servers are being deployed now, have that 10G base T capability. A lot of other capabilities too that are driving that, but we're seeing really solid growth in that 10 gig. Here's some stats on the terabits of traffic from the Summer Olympics through I think the London Internet Exchange. Just more charts for you. Here's a HSE consensus a consensus ad hoc, where we're starting a new forum in the IEEE so that we can discuss what the next speed of Ethernet is. So this is an active group. We'd love to have people like you come in and present to us saying why you need the next speed now. 100 gig isn't fast enough for us. Give us more, right? So we did a survey last month in Geneva. We did a straw poll and it was unanimous. Everybody wanted 400 gig except one person was a stalwart, wanted the rate to be selected later in the study group. Terabit, this is a bunch of engineers. We just didn't think it was practical and low cost enough. Basically, the group wants to do 400 gig at a limited scope really quickly. I'll go into more detail on that. We also came to agreement that we want to do the call for interest, or CFI, in March. So it's coming quick. It's probably at least a two-year development cycle from that. So 2015, 2016, we should have a standard for that, depending on what objectives we decide. So let's look at that a little bit. So first, let's consider the options. How can we go at 400 gig? So a little recap of 100 gig is it's 10, from electrical interface, it's 10 lanes of 10 gigabits per second. Right now, we're defining the second generation in IEEE, which is 4 lanes of 25, so 2.5 times power or faster per lane. We're looking at some advanced modulation techniques, but it looks like it'll continue to be NRZ, or non-return to zero, so just simple on-off keying. So to go to 400 gig, the prevailing thought is that we'll just do 16 lanes of 25 gig. So just take 4 of those lanes that we're going to have in this new generation, multiply it by 4, now you have 16 lanes of 25 gig. We could also do 10 lanes of 40 gig, but we don't have a standard for how to do 40 gigabit per second yet. Or we could do 8 lanes of 50, looks very promising as well. I was in Kauai last week with the Optical Internetworking Forum. I highly suggest having a meeting there. It was really nice getting to Hawaii. It was rather cheap too. I mean, it was like $150 a night for the hotel. So you guys might look at going there in the future. I really liked it. Anyway, we're defining 56 gigabit per second electrical interfaces there. We're just starting that. It's probably a 3 to 4 year effort. The same rate is going to be used for 64 gig fiber channel. And it also defines 40 gigabit serial as well. So 40 to 56 gig for serial lanes. So you take 8 of those and you got 400 gig. Now looking at a terabit, we're talking 40 lanes of 25 gigabits per second, and we haven't even defined that yet of how to do the 25 gig. We're getting there. I mean, that's what we're doing in the IEEE right now, but it just takes a lot of effort. We're going against the laws of physics here again, of trying to get a long distance over that fiber. We have Shannon's limit working against us. There's a lot of electronic tricks and forward error correction and different things we can do, and we're throwing everything we got at it. And we're going to get there at 25 gig, but we need to make it low cost and low power. I mean, there's pretty good correlation between something that's high power and high cost, not only from operating expense, but from CapEx expense as well. So, but after we get those 50 gig, we could do 20 lanes of 50 gig. That's still a lot. If you guys know, like the CFP form factor supports 12 lanes of 10 gig today. And that's, again, about the size of a cell phone, the latest 100 gig module that's being deployed today. We're defining one half the size now of CFP2, but we're at least a year away from production on that. So anyway, terabit is just too many lanes at not high enough speed. We're going to get there, but it's going to be 5+ years out, it looks like. But we know how to do 400 gig in the next couple years, so that's why we're doing that. I basically already answered this question. It's just mainly economic feasibility and technical feasibility. Now here's what we're going to be deciding in 400 gig is what PMDs or what physical variants you have, we have to define. So right here I show all the PMDs from 100 meg to 100 gig that's in the data center. On the far right you can see the dark blue is single mode fiber. The light blue, doesn't have as much bandwidth length product, so it's shorter distances in the light blue. We have twisted pair. We've had a lot of problem getting to 100 meters at 10 gig. So we're looking at 40 G-base-T right now, defining the objectives for that, and it comes back to this reach media thing. If 10 G-base-T had only been defined at 10 meters for top-of-the-rack switches, we could have done it really quick, it'd be really low power, and it'd probably be deployed everywhere. But we had the objective of going 100 meters, so it's very difficult to make that in the technology of the day. Now we're getting to that point where 10 G-base-T is being deployed now widely. So going over one step from that, you have the fuchsia color twin ax, then we have the backplane applications that are about 1 meter, and then we have the electrical interfaces, which are a matter of inches. So I should have explained this at the start. We have distance in the logarithmic scale on the bottom axis, and we have speed going up in the other axis. So we're doing a lot of projects right now at 100 gig, or 2 projects. We're doing all these different PMDs that you can see by these empty circles. So these are subject to change. They're not standardized yet. The backplane ones are getting pretty close. But we're going to have 11 different physical variants or interfaces at 100 gig. So you can see like at 100 meg we had 3 different variants. 1 gig we had 5, 10 gig we had 6, 40 gig we're going to have 7 after that. We're defining 40 kilometer at 40 gig right now. Then at 100 gig we're going to have 11 variants. So for 400 gig, to do this quickly, we can't define that many number of variants. I would hope that we'll do like 3 variants, one for probably 10 kilometer single mode fiber, another for multi-mode fiber to maybe 100 meters, and then the electrical interface of 16 by 25 gig. So this is where, let me just progress on. So if we pick a whole bunch of things, or we pick to do 50 gig serial lanes, this project will take 5 years. If we just do 16 lanes at 25, we should be able to do it within a couple, 2 to 3 years. And we'll be starting in March. So the Ethernet Alliance, to support this effort, we just started a 400 gig subcommittee. I'm the interim chair for that right now, so I'm getting all these requests. Everybody's really interested in this new study group. What we're doing is building consensus for 400 gig to understand if there's a broad market potential, what reach we're going to have, and what media. So the broad market potential is basically how many ports of 400 gig are we going to ship in, say, 2015. If it's 10 ports, then it's really hard to justify the project. We need thousands of ports leading to millions of ports to substantiate or make the investment worthwhile for the whole Ethernet industry, right? I mean, to get to 100 gig now, we've invested hundreds of millions of dollars. Individual switchblades can cost tens of millions of dollars to develop. So if we only sell hundreds of ports of these, it's hard to get back that investment. We were trying to get one to do 400 gig at the right time when thousands of ports are needed so that it's low cost again. That's our new mantra in the IEEE is it has to be cost effective per bit. It has to be 400 gig has to be less than 4 times the cost of 100 gig to make it widely deployed. And of course, those are all seeing these exponential drop off in price as well. So reach and media, again, that's real important. If we pick, right now we're really sweating it, defining 4 lanes of 25 gig to 100 meters. That's where it looks like we're going to use FEC and equalization and retimers, all this stuff to get to get to 100 meters. So to summarize again, the bandwidth we're growing, on average, we think it's about 58% every year. That means it doubles every 18 months, and every 5 years it goes by a factor of 10. Every 10 years, your traffic today is only 1% of what it'll be in 10 years, 100 times growth. So there's some rules of thumb that hopefully you can remember. And, and judge your industry. Is it growing less or more? If you're in the mobile phone industry, you're growing more than that probably. So we've created in the IEEE the Consensus Ad Hoc, and we're developing the consensus to do a CFI to start the standardization in March. We expect it to be 400 gig. We have pretty good consensus on that. What we don't have is on the physical layer specifications, the reach and media. That's where we could have your input. Do you want a new type of parallel fiber, ribbon fiber that's 16 fibers instead of the standard 12? We'd love for you to come to the Ethernet Alliance and tell us what you need, as well as you can go straight to the IEEE if you have the resources. So thanks for your time, and please feel free to come to me and tell me your stories about the growth that you've been seeing. When I go to data centers, these guys come to me and they're like, oh my God, everything's growing so fast. I have 1,000 things to deploy within the next 2 months. This growth is just crazy. So I'd like to hear those stories, and I'll pass them on. So,
Sounds good. I believe we have a question.
Randy Bush, IIJ. It's really cool that you've seriously enhanced the presentation from the one 5 years ago, aside from just adding the 0 and changing the dates. But it's the same excuses, the same numbers, except multiplied by 10. How much 40 gig ether did we really use versus finally, once you came through, hopping to 100? Come on, we're going through the same thing. Can't we learn from last time? We understand you want to wait until there's enough need that it's commodity and it pays for it. That's cool, but can we focus on the goal, not the...
Okay, so this is what I was trying to tell you, is there's the network perspective and then there's the server perspective. So the network is growing at that 10 times rate, but the servers aren't. They aren't growing that fast. So what we're seeing now is more 40 gig is being deployed than 100 gig. I mean, we wanted to do a survey.
I heard you 5 years ago.
Okay, so we can do both.
Same story, just move the decimal point.
Well, we're not doing it. We will do terabit, but I just tried to show you how we don't know how to economically do that. We know how to economically do 40 gig in a QSFP today, though. That's what we're seeing wide-scale deployment. What's nice about 40 gig 2 is we break it out into 4 lanes at 10 gig with octopus cables. So we see that being widely deployed and cost-effective.
Any other questions? We have time for one more question. Okay. Thank you very much, Scott. That was great.
All right. Welcome.
So it's time to leave the meat locker and go to lunch. Sorry about the temperature in this room. We will reconvene at 2:30, And I just want to make one quick announcement. Nominations are still open for some of the NANOG committees. So if you're interested in being on a committee, or if you're interested in nominating someone else for a committee, you can either talk to Randy Epstein or you can talk to folks at the membership desk as well. Thank you very much. See you soon.